Section 9.4 is on triangles. The definition, we have a few definitions to talk about before we talk about a triangle. A line segment is a part of a line that contains endpoints. It has a beginning point and an ending point. So that right there would be line segment AB. A triangle is a figure that's formed by three line segments that intersect only at their endpoints. So I'm going to name this triangle A, B, C, and you can see it's made up of line segment AB, line segment BC, and line segment CA. These are considered sides of the triangle, and these of course are the angles of the triangle inside. We've learned how to measure those. And then of course this point out here on the outside, like that's point C, that's called a vertex. And when we have more than one of them, we call it vertices. So I have a vertex at C, a vertex at A, and a vertex at B. And I literally would name this triangle A, B, C. Now I can put the ABC in any order I want. I could name it CBA or C or ACB. So I can go around however I want on this triangle. I can start at any spot. Angles of a triangle always add up to 180 degrees. So the measurement of X, the measurement of Z, and the measurement of Y, when I add those three together, if I were to measure them using a protractor, or perhaps they give me the measures, are going to always add up to 180 degrees no matter what the triangle looks like. So a typical problem on this might be that they give you these 2 points, or these 2 angles. They give you angle B is 58 degrees, and angle C is 55 degrees. So the first thing I'm going to do is I'm going to add the 58 and the 55 together, which of course is going to give me 113. And then I'm going to take 180, which is what the angles should add up to, and I'm going to subtract the 113 from the 180, and it's going to give me 67, which means that angle right there would have to be 67 degrees, because then I know that 58 plus 55 plus 67 gives me 180. All right, here's another one. I've got 100 and I've got a 33 right here. So I'm going to go 100 plus 33 equals 133, and I'm going to take 180 and I'm going to subtract 133 from it, and that's going to tell me what my angle that I don't know is equal to. So that's going to give me a 7, and that's going to be a 4. So this right here would have to be 47 degrees, because 33 plus 100 plus 47 is going to give me 180. Sometimes you don't know any of the angles on the triangle, but you know the ratio of the sides. Like for instance, the measure of the angles of a certain triangle are in the ratio of 1, 4, 7. What are the measures of the angles of the triangles? Well, if the angles have to add up to 180, obviously the actual measurement is not 1, 4, and 7. We don't know what the actual measurement is, but we know that they are related in such a way that if I took 1x plus 4x plus 7x, it would have to equal 180. And we've got to figure out what that x is so that we can go back and figure out what the angles are. So I have 1x plus 4x, which is 5x, 5x plus 7x, which is 12x, is equal to 180. So when I divide that by 12, I'm going to get 15. So x equals 15. So therefore I can go back and I can plug it in, and I know I have one angle that's 15 because I have 1 times 15. And then I have a second angle that's going to give me, that's going to be a 60 because 4 times 15 is 60. And then my last angle is going to be 7 times 15, which is going to give me 105, I believe. Yep. Okay, so those angles would be 15, 60, and 105. And if you added those together, you would end up with 180. All right, let's do another one. I have a ratio of 2, 3, and 5. So I go 2x plus 3x plus 5x equals 180. So that's going to give me a 10x is equal to 180. I'm going to divide both sides by 10, and x is going to give me an 18. So I go 2 times 18 is 36 degrees. 3 times 18 is going to be 54 degrees. And 5 times 18 is going to be 90 degrees. Okay. Triangles can be classified or named by their angles. So if all of the angles are acute or less than 90, this is called an acute triangle. If one of your angles is greater than 90, and only one of them could be greater than 90, it's what we call an obtuse triangle. So you've got an angle on there. The 100 degrees is greater than 90. So if you have one angle that's greater than 90, you have an obtuse triangle. If you have a right angle or a 90-degree angle, you have a right triangle. They can also be classified by their sides. So on this one, if you'll notice, and congruent sides have the same measure, this side, AB, is congruent to CB. And you'd see that because they put a little mark on both of those sides. If two of the sides are congruent, this is called an isosceles triangle. Now these are based on the side measurements, not the angles. This one doesn't have any markings of any sides that are congruent, so this is what we call a scalene triangle, which simply means none of the sides are equal. And on this one, all 3 of the sides are equal, so this is called an equilateral triangle. Okay. All 3 sides are equal. So let's practice. Now sometimes we classify by both angles and sides. So we're going to look at the angle first. Notice that it has a right angle, so it is a right. Now we're going to look at the sides. 2 of the sides are congruent, so it's a right isosceles triangle. This one has a obtuse angle, so it's an obtuse, or an angle that's greater than 90, obtuse. None of the sides are congruent, so it's an obtuse scalene triangle. All right. 2 more. If I'm looking at the angles, we have all acute angles. If I'm looking at the sides, it's an equilateral triangle. Okay, 1 second. I knew that other looked wrong. So let me change the spelling here. Okay, this one should have been an I right there. I thought it looked wrong. All right, this one. If I look at the angles, I have a right angle, and none of the sides have congruent marks on them, so it's a right scalene triangle. All right, your homework on this is page 456 through 457, 11 through 29 odd, and 34 through 36 all.